Hey guys, welcome to lesson 721, day 3. Today we are going to learn about graphing the cosine function with transformations. So a lot of this will be very similar to when we graphed sine functions yesterday, but now we just will have a little bit of a different shape to the curve because of course cosine and sine are after all different curves. But we have the same components here, A right over here at the front for amplitude, where we get stretches and compressions, H for left and right phase shift, but again, we don't really worry about that in our class, and K is for the vertical shift, which also serves as our midline. So we will start by creating our table for the 5 points that we're going to be using to graph, just like we did for sine. So let's go ahead and fill out this table here, and remember that it's cosine comma sine in these parentheses. So fill out the table accordingly. So at 0 radians, we want the cosine, and that's the left. So this left number right there, the 1, that's going to be the cosine. At pi over 2, we're looking over here now, cosine is the left number, that's this 0. At pi, left number is -1. 3 pi over 2, left number is 0, that's the cosine. And then 2 pi matches with 0, they're both in the same spot, so the cosine is 1 here as well. All right, so notice the symmetry going on in this table. All right, that's a good indicator that our graph is also going to look symmetrical. So with sine, we had our little 5-point trick, and cosine, we're still going to use the 5-point trick, but it's just going to look a little different. So with this one, we have our 5 spots, and the way it works is you start high, you go to the midline, you go low, midline, high. Right, and of course, if this was flipped, it would be like this instead. But this is just like your basic positive cosine function. So let's actually graph these on our graph. So 0, 1 will fall right over here. Pi over 2, 0. Remember, this is x and y. So pi over 2, 0 will be here. Remember, we are ignoring all the pi over 4 intervals. Pi -1 will be right over here. 3 pi over 2, 0, and 2 pi, 1. So once you have plotted your points, you can go ahead and draw your curve. I know the dots look pointy, but sine and cosine curves are smooth and graceful, so we gotta try to make, that's bad. Let me pause this and then make my curve. All right, could be worse. So this is the parent function of cosine. Now, I have these side by side so that we can make a couple of observations about them. Notice how midline starts high, right? And now, remember, I told you here that midline, or cosine, can also start low, depending on if you have a reflection. So something to note about cosine is that it always starts either at its highest point or its lowest point. All right? Sine, on the other hand, starts always at the midline. We ignore this. That's another cycle. But right here, the very first point is always going to be at the midline. Okay, notice this S-shaped curve too. S for sine. So if you see an S-shaped curve, you know it's going to be a sine graph. Cosine, on the other hand, looks like a hole in the ground or like a ditch. Or a mountain, if it was flipped. All right, so let's do some practice with this. Here I have the parent function drawn for you so that you can just adjust it to be the transformed one. So remember that the general form is this, y equals a cosine x minus h plus 2. Or sorry, yikes, plus k. That kind of gave this away, didn't it? So we look at our equation, we're like, okay, well, there's no number where a would be, there's no number where h would be, but there is a number where k would be. So this is going to be my k, which the k also functions as the midline. So we can go ahead and write our midline equation, y equals 2. And let's go from there. So we know that k is responsible for moving us up or down. So this tells us that we're going to be moving up by 2. So all I have to do is take my points and scoot them up 2 places. This is going to go off our graph a little bit. That's all right. So we'll go 1, 2, put that like here-ish. This would be where 3 would fall. And then this point, 1, 2. Remember here I'm not counting the boxes because 4 boxes is worth 1. And then this one goes 1, 2. This one 1, 2. And this one will go up 1, 2. This one's also up at our imaginary 3. I'm going to pause recording to draw the curve. All right, I have drawn in my curve, so this is the final transformed graph. It's just the moved up version of the original one. All right, so next we have, oh, I should probably talk about this amplitude. Remember, the amplitude is the distance between the midline and the highest point, or the lowest. Remember, it doesn't really matter. Same thing. So if we were looking at the midline right here at 2, that's terrible. All right, so we have our midline here. Now the distance between the midline and the highest point would be, the midline's at 2 and the highest point is at 3, so that's a distance of 1. And again, you can use the peak as well, so like if we got this distance, it would also come out to 1. Either way, you can find the amplitude with whichever one of those you prefer. All right, now we're ready. Here we have the graph of the parent function again, and we have to make 2 cosine x. So this is just cosine x. Now remember, this is the general format, all right? A cosine x minus h plus k. So our equation has something in the place of a, right? This 2 functions as our a, and I'll just write it again for fun. All right, so this tells me that I'm going to be stretching by a factor of 2. So that 2 is also going to serve as our amplitude. A is the amplitude. All right, so now the way you're going to stretch this is by taking all of these points and increasing their vertical distance. So because this is a vertical stretch, all we have to do is take the y value and multiply it by our stretch factor. So for this point, it's at a y value of 1. So you'll do 1 times 2, and it's 2 because that's our a. So I get 2, and that means this is going to move up to 2. My next one, this is actually at 0, right? So 0 times 2 is still 0. So this point actually doesn't move. Okay, this next one, it's all the way down at -1. So -1 times 2 equals -2. So we're going to take this guy and move it all the way down to -2. And then here, we're back at 0. And we know what happens at 0. It just stays where it is. And then this one's at 1. And so we know it's going to move to 2. All right, let's pause recording and draw my curve. All right, here's my stretched out curve. So this is my final product. All right, and as you can see, whenever you're just stretching, the points that are on the midline don't move because it's like you're just pulling the higher and lower ends. It's like stretching a rubber band. All right, let's practice writing some equations now. This one, you got to first start by recognizing, is it sine or is it cosine? Now remember, a couple of notes to write down here. If I am working with cosine, my regular positive graph would look something like this. Okay, that's a regular positive cosine. If I were to flip it and there's a negative sign, then you turn into more of like a mountain structure. So this is your options for cosine. Now for sine, we have our S curve. So it's either going to look like this when you have a positive regular sine curve, Or if you flip it, it will look like this. And that's our reflected one. So that's just something to keep in mind, all of these shapes. So this will help you select whether you're looking at a sine curve or a cosine curve. So this one, it looks like a ditch, right? A hole in the ground type of thing. So you know it's going to match with cosine. All right, so the first thing you always want to figure out when you're looking at a graph like this is the midline. That is your best bet. All right, so you look at this and you're like, my highest point is at -1, my lowest point is at -3. So the middle of that is going to be right here at -2, which means I will go ahead and take my pen and draw a line here. That is my midline. So I can go ahead and write down that my midline is at y equals -2. You always want to start with the midline. This will make your life much easier because the amplitude depends highly on the midline. So the amplitude then is the distance between the midline and the highest or lowest point. So if I looked at the midline right here and the lowest point right here, I can see that this distance is a distance of 1. So my amplitude is 1. All right, and is this a reflected graph? Now we have to look back up here and ask ourselves, well, does it look like this one or this one? We can see that this one goes downwards, which matches the positive, which means that there is no reflection. Right, so we know that the amplitude is the k value. We know that the midline, amplitude's not k, that was bad. Amplitude is the a value. The midline is the k value, and reflection would give us a negative sign, but we don't have to worry about that because we're not reflected. So going off of our general form, wow, I'm just making a lot of mistakes today. Too lazy to re-record this. So, all right. So this is what we're working with. Now, we just have to plug in our pieces. A is 1, so we'll put a 1 where A is. Cosine, we don't have an H. We're just not going to have H's ever with this. And then K is -2. So that is my final equation for this. And it makes sense. If you look at your equation, you're like, this just means moves down 2. And that's exactly what happened to my graph. Okay, so now let's look over to this one. Obviously, this graph looks a lot different from this one. That's because this is indeed a sine graph. S for sine. So remember what I said step 1 was find the midline. So the highest point is at 2. The lowest point is at -2. So my midline here is just going to be my default of 0. The amplitude, we got that space between the midline and a peak. So this is 2. So that tells me my amplitude is 2. And was it reflected? Well, let's see which one of these it looks most like. In our graph, from the midline we went down, and that seems to match what's going on in this picture. So it is the -1, which means it was reflected. All right, so that means we need to have a negative sign. The 0 midline means that our k is 0, and the amplitude means we have a value of 2. All right, so now following this exact general format, we can write our equation. Y equals negative, don't forget about that negative sign, it's easy to forget about. A value comes next. Cosine of x, and then our midline is 0, so you don't have to put anything else here. You could just be done, or you could put a +0 on the end. Okay, either way works. If it's a +0, then it really doesn't matter because it doesn't do anything to our graph. All right, so real quick, before I run out of recording time, want to show you guys something. And that is that on my open math, you just have to be very careful. If I'm graphing my parent function on here, you just want to make sure that your second point that you pick is the peak. So you have to put your second point right here at pi. you don't plot the one at pi over 2.